Welcome to our presentation on 3D printers. To produce an object from a 3D printer, you must first start by creating a 3D model on a computer. The model is typically created using CAD software. This software allows you to create a digital model of the desired object and then send the file to the 3D printer to be printed. But before the model is sent to the printer, the model must be sliced digitally into thousands of horizontal layers using a slicing software. After the model is sliced, it is then sent to the printer by either USB, SD, or Wi-Fi. Then the printer uses a process called fused deposition modeling, which deposits layers of either molten plastic or powder on top of each other to create a three-dimensional object. This process can take either a few minutes for small and simple objects or several hours for larger and more complex objects. The first picture shows a MakerBot Replicator Plus 3D printer creating an engine block. This specific 3D printer is a very advanced and expensive 3D printer that costs nearly $3,000. The second picture shows the fused deposition modeling that is used in nearly every 3D printer today. Even though 3D printing may seem like a very advanced technology, the first applications of 3D printing go back to the 1980s. In 1981, Hideo Kodama of Nagoya Industrial Research Institute invented a method to create simple 3D objects using polymer. The next breakthrough came in 1984 when Charles Hull invented stereolithography. This method allows designers to create a digital 3D model which is then used to create a real object. This method is still used today. Then in 1988, fused deposition modeling was created. In this process, filament is fed through a heated extruder and then is deposited onto the other layers of the object. Then in 1995, selective laser melting was created. This process adds on to FDM, and it uses a laser to melt the plastic or polymer fully, which creates a less porous object. This increases the strength of the object without having to add more material. Soon after, in 1999, the first 3D printed organ was implanted in a patient. A synthetic bladder was printed, and then it was covered in human cells so the body wouldn't reject the organ. Advances like this show that the future of 3D printing is very bright, as researchers are looking for ways to produce vehicles, planes, and even human body parts from 3D printing alone. As for the average citizen, 3D printers are becoming more affordable, allowing everyday people to produce 3D printed objects.
These images show scanning electron microscope pictures of PLA filament, which is the material used by 3D printers to make objects. By looking at these pictures, you can see that the printer is capable of high accuracy when placing the material, which allows printed objects to be very detailed. In addition, the material is placed in layers, which makes it possible to make many structures that otherwise couldn't be made. The most commonly used filament for 3D printing is polylactic acid, and it comes in large spools or in a pellet form for industrial use. The printer works by forcing this strand of plastic through a heated nozzle called an extruder. The filament is heated to its melting point while going through the extruder, and it's deposited onto the printing platform. The extruder head is moved by motors in the X and Y direction for each layer, and when the layer is finished, the head is lifted slightly in the Z direction to start the next layer. This is a specific type of 3D printing called fused deposition modeling, and it is one of around 10 different types. Other types include stereolithography, which prints by shining a UV light on resin to selectively harden it, and selective laser sintering, which prints by heating powder to just below its melting point and using a laser to selectively sinter some of its powder. PLA filament is made from the material polylactic acid. This material is useful for 3D printing due to many of its physical and chemical properties. PLA can be melted at between 180 and 220 degrees Celsius and doesn't burn anywhere near these temperatures. It also resolidifies very quickly, making it perfect for this specific type of printing. It has high tensile strength, making it so that prints are stable and not easily breakable. In addition to these good qualities, PLA is biodegradable and easily made from renewable biomass. This means that it is a safer choice for the environment than other plastics, which require petroleum and will last for many years, because PLA will degrade within 2 years if subjected to the elements. Although PLA is a very good material for many of the applications of 3D printing, no material is perfect for everything. For example, PLA has a low glass transition temperature of around 110 degrees Celsius, meaning that it will become soft and deform in these conditions. Because of this fact, one of the most important parts of 3D printing is the choice of material, which will be different for the many different tasks that can be accomplished with them. In certain applications, a non-degradable material such as a ceramic filament.
Copper is found in the motherboards of 3D printers. Copper is also found in other electronics, coins, and is used as a sheath for composite heating elements. Close to 80% of all copper is extracted from sulfide sources. It is typically found in oxide and sulfide ores that have between 0.5% and 2% in them. It is unknown when copper was discovered. Reports say copper beads date back to 8000 BC in Turkey. The largest copper mine in the world is found in Bingham Canyon, Utah, in the United States. Copper is used as electrical equipment like engines and wiring. Copper is also commonly mixed with other metals to make brass and bronze. In the economic world, copper is referred to as Dr. Copper because copper has the ability to gauge a precise prediction of an area's economic vitality. Copper is both an excellent electrical conductor and heat conductor.